Hello and welcome back to this Introduction to Coding series. I am your host, some guy with a crappy haircut. And today we're going to be talking about one of the most important things in C and C++ that you can learn, and that is pointers. And the reason why I consider it the most important thing you can learn is because of the way I was taught it. And I'm just going to go into it very, very quickly and then we're going to move on. When it was the week before, the lesson before in uni, my lecturer just goes, "Don't care what happens next week. Arm falls off, your dog dies, I don't care. You come to class because we're learning about pointers and they are the most important thing you will learn." And he was right, in my opinion. He was very much right. They are extremely difficult to understand. And on top of that, they can cause so many headaches, but they are so powerful, like most of the things in C++. Now, pointers are a fairly unique concept, at least directly exposed to the person programming. It is a unique concept. Things like C#, Java, Python, Ruby, in the background all have pointers and ways to work with them, but they don't generally expose it to the end programmer, not the end user really. They do all the magic behind the scenes and it just works. Whereas C++, it doesn't hold your hand, and C by extension. Just assume it's C by extension when I say C++. So in C++, it's very powerful because it doesn't hold your hand, but it's also extremely scary because you can fuck up very easily and cause things like massive memory leaks and stuff like that. So let's talk about this really simple example I have on the screen here. So this very simple example, what I'm doing is, well, you can know if you're watching this, you know what's happening here. Let me just change this back to what I had because I was dicking around with it for a bit. I started recording this and it went really badly, so I stopped. So let's run this and we'll notice a couple of things straight away. So first things first, even though I'm changing this value A that I'm passing into 5, it's still 3 when it outputs. And the second thing is up on the top left here, we'll know this is our memory profiler, which has changed because I hit a breakpoint. It's sitting at 1 kilobyte, 1,000 kilobytes, so 1 megabyte of memory, or 912 kilobytes of memory. And it's not moving. We are creating a int every time we go through this loop. And what's happening is when it gets to the end, this A is falling out of scope and it's getting deleted. And then it goes through, makes it again, makes it again, makes it again. This is a really shit piece of code for so many reasons. You shouldn't be doing anything like this, especially while true, even though my game engine has while true, but we won't go into my shitty coding right now. Thank you very much. So, pointers. What are pointers and what can you do with them? Pointers are, if you can't imagine, things that point at other things. They are variables that point at a memory address for another variable. And these are extremely important for a lot of reasons. But the first reason here I can show you is this thing here, where we're trying to set the value of this variable to something else. But what's happening here is when we call this function, it's actually creating a copy of our data. Now, this is bad for a couple of reasons. The first reason is that if it was anything bigger than an int, say it was a bitmap or a game object or some other massive thing. Maybe you have a 16K texture that you're copying through memory to run through a filter or something. It would have to create a copy of that texture. And that's bad. That'd be very, very slow. And you can imagine if you're running it through like a filter chain where it does like 15 things, you'd have to copy it, then 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 copy it. And every one of those filters might have more stuff it does with that thing, so I have to copy it again and copy it again. And it'd be incredibly slow. And on top of that, the worst part is every time you copy it, it's a copy. So you'd have to return that object back, which is making another copy of the edited object, and then storing it, which is copying it again. So it's so incredibly slow. With pointers, what you can do is, much like a map, you can go, all right, I'm going to give you an address. And at that address, there is what you need to work on. The advantage of that is a pointer will only ever be 8 bytes if you're working on a 64-bit system and 4 bytes on a 32-bit system. That's the most it can ever be. Actually, that's all it will ever be. It can't be less than that, to be honest. And secondly, it allows you to then do something like this because you have a direct access to the data. If I tell you where my house is, there's nothing stopping you from breaking in and rearranging my furniture. But if I give you a copy of my house, which would be impressive in so many ways, and you ruin your furniture, my furniture is going to be fine. It's a great, perfect analogy, and there's no holes in it whatsoever. So let's talk about pointers in a more basic sense. So let's say we wanted to convert this to pointers. How do we do that? Well, there's a few ways we can do it. And let me just bring up my notes because I cannot remember things because my brain is broken. Alright, cool. So the way we use pointers is extremely simple. Extremely simple. So to convert this to a pointer, we just do this little star. Now, yes, there's errors. Ignore those for now. So let's do that. What we have done here is create a pointer to an integer and called it A. So what this A is actually storing is a memory address. So if I go here and I just not go through a loop and I just stop the code here. It's a really roundabout way of doing it. Could you not? Okay, it's not letting me do what I thought it would do. Let's just make this equal to 0, which is what we want. Now, 0 in this case is a very special number. 0 is a empty memory address. Now you'll notice there's 8 numbers there because it's the memory address for 0. It is at the very, 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 very top of my RAM. Generally speaking, you are not going to be using that memory address. That's usually reserved for things like everything else. And as a result, we set 0 or null, which is the other way to say 0 in this case, as like an empty memory address. So what we've done here is created, let's change it over to null, something, a pointer that is empty, points to nothing at the moment. So now what we can do is actually give that thing data. Now, I'm just going to double check because when it comes to this like basic shit, I don't generally do it. Like I can't remember the last time I created a pointer to an int. Like literally ever. So the way we can do this is we have to actually create an object to store the int in. Because at the moment, all we have is a pointer. We have a memory address, so we have an address to someone's house, but the house is currently just a block of land. So we need something to store that block in, that piece of data in. So we do this by using what's called the new operator. And the new operator does exactly what you think. It creates a new integer. Or a new whatever. In this case, it's an integer. And what it returns is a pointer to that object. So it's kind of hard to see what it's doing here. But anyway, now if I output A, it should hopefully give me something. Yeah. So it's giving me a memory address. FC8BFO. Beat the fuck out. Sweet. Wherever that is in my memory is where it is. It doesn't really matter. So let's just do that. So we've created a new int. And now we can go and we can give that int some data. So we can go A is equal to 5. Wait, what's going on here? Why do I have an error? A value of type int cannot be assigned to an entity of type int star, or a pointer to an int. What we are trying to do here is assign the pointer address to the number 5. And those two things aren't compatible. Okay, so how do we do that? What we need to do is use the star operator, or the @ operator. I think both work. As I said, it has been an exceptionally long time since I've done it with this kind of basic shit. It is the star operator. So what this is now saying is go and assign the value of A to 5. And then this one, how do we then output it to the screen? Well, it should just work like this, to be honest. I don't think it's going to. I think it's making me out to be a liar. It has. Okay. What we then need to do is do what's called dereferencing. We need to go in and get our data back out. So we can use the @ and the @ is for going one level the opposite direction, because I'm an idiot. We need to use star, sorry. Yeah. As I said, been a while since I've done this kind of basic stuff. So now we got the number 5. So you're probably thinking at this point, what is the point? And I do not blame you. Yes, pointers drive me to drink. What is the point? All right, let's do this. Let's change this function and go funct a. Okay? This value here, as opposed to what happened before, is now 50. Because we've given them the keys to our house and said, go fuck my shit up, and we've allowed them to do that, rather than giving them the copy of our house. So that's one cool thing we can do with pointers. And that's the most basic thing you can do with pointers. With integers and stuff like that, it's not as important. But as I said, when you're thinking about like large scale things, like thinking about a sprite, or maybe you have some kind of camera, like auto-scrolling camera in a game, you can pass them the camera, this auto-scrolling function, and it will auto-scroll it for you. You don't have to go tell them, oh, this, give them a reference to the camera somewhere else and how they work. This will just work for you. That's cool. All right, cool. So this is simple enough. So you were saying that we're dangerous. Well, what's so dangerous about pointers? Wow, this is where this while true comes back in. So I'm going to stop it from outputting to the screen, and I'm going to stop it from being edited through this function. So it's just going to be these 3 lines of code. Now I want you to watch the memory usage on the left when I start this program, okay? Holy shit, I'm at a gig. Oh my god, I'm at 2. How long until my computer crashes? I've actually plateaued at 2 gig of RAM. That's actually incredible. That's actually stopped. So, and I've run out of memory. So what did it actually get up to, I wonder? Where is lesson 9? It's actually just, okay, it's already crashed. So let's bring it over there so we can watch it together. Oh no, it's gone up to 2 gig. Ignore all the rest of this crap. I honestly don't know what half of it is. I need to format my computer. So bad allocation at memory address that. So we've run out of memory in the space of 20 seconds. What's happening here is we are creating a pointer to an integer. We're then creating an integer object. And then we are assigning it value, and then the object is falling out of scope. But the issue is that it's only our pointer falling out of scope, because the integer we have created with the new operator, we're meant to be the ones managing that. The reason for that is if I want to, say, create a new integer like I have here, and I want to pass it to you, and you're going to manage it over there, I then don't want to delete it. I don't want it gone. I want you to be able to manage that. I've created the object for you. I've initialized it. It's ready to go. Here are the keys. This is really useful for things like initializing, say, a video player. And I can give you a handle to my video player and say, hey, whenever you're ready, just tell me what file you want to play and I'll know what to do with it. But for now, I'm turning myself off until you're ready. And that is how VLC works in the background. You can actually download the VLC libraries and make your own video player out of it. And that is exactly how it works. Because I've had to do that before with my last work. Because it's all free, so they like free stuff. So that's one reason why pointers are really great. I can offload something once I've done working on it back to you, and I don't have to worry about it. It's not going to get deleted, excuse me, and I don't have to make a copy of it to offload it to you. You don't have to make a copy of it to give me the initial object, and you can pass it back and forth. But you have to remember that someone needs to clean it up. Otherwise, it just keeps getting created, and then all of a sudden you've lost the handle to it. Much like losing a winning lottery ticket, you can't claim your prize. It's just stuck forever. It is wasted money. So the way we do this kind of cleanup is with the opposite of the new operator. We use delete. Delete A. What we're doing here is deleting the object that is pointed to by A. So now we run this, and it should set at a meg, which it is. It's sitting at 9099k as before. Because even though we're creating it at the same pace and creating as many objects, and we're still creating it using pointers, what we're doing now is cleaning up after ourselves. And this is where you get memory leaks, and you've got to be really, really careful using pointers. You will get a memory leak. I can guarantee it. If you build something more than what I've got here, you will get a memory leak. There's no ifs, whens, or buts. You will. It's just going to happen. The important thing is learning how to sort of go through and say, well, you know, who's responsible for this memory? Should I be cleaning it up? Should you be cleaning it up? And things like VLC do that. You have to know who's responsible for that memory. After I pass you the handle to my video player, you're responsible to it. But if you give me like a file association or something, not a file association, like a file path, I'll do what I need to do and then I'll clean it up because it's not needed anymore. It's done. That is the important part of pointers, knowing when and where to clean things up. So this is an extremely simple version of pointers. And to be honest, they can be this simple, just using new and delete, and you can do some pretty funky stuff. But let's talk about one of the actual useful things you can do with pointers at this very basic integer level. So let's say I'm going to create this function and I'm going to go, but I'm not going to change the data. Okay, I'm just going to call this function A. We are passing an empty reference. It doesn't know what this is. We haven't actually created an object yet. So we can go into here and go, if A does not equal to null, then we will change the value to 50. And this is really hard to demonstrate. Actually, no, it's not. I'll go else. Null, oops. Null detected. Now, you're already thinking, what is the point? What is the point of this? So it's just going to go on and on, null detected, because I haven't actually created anything. What is the point of this? The easiest example I can come up with, okay? If you have an array full of data you've loaded, and it's identifiable, you've loaded it from a file, so it's like a phone book, and it's identifiable through a name, like a phone book would be. So you go and go, in this phone book, please search for the name Jason Ashman. All right, cool, I'll do that. Hey, it wasn't found. If you're expecting a return type, and I'll do it here. If you're going to do, let's just create a struct. Call it a phone book entry, PBE. It's just going to be string name and int number. You shouldn't use an int to store a phone number. Many reasons why, because you can only go up to 12 digits, 10 digits, which isn't very useful because Australian phone numbers are 10 digits by default. So if you want to include an area code, you're shit out of luck. But then I create a function called search, which returns a phone book entry, and it searches on name. How do I then convey to the end user that I haven't actually found someone named Jason Ashman? There's no real way I can do that in this current setup. I have to return you an empty PBE. And that's horseshit because I'm expecting something back. So I'm just going to go, I found this number for you, but the number's empty. That's ridiculous. What you can do is then change this to a pointer. And then you can go, you know, find code here. If found, return object, return PBE. This is exactly what search code usually is. If not, return null. So now we're returning nothing. We are returning an empty object. And then down here, I can go, you know, PBE star object is equal to search for name. And then I can go if PBE is equal, oops, object, sorry, is equal to null. Or actually, probably the more actual codey way of doing it. If it's not equal to null, I'm going to do a bunch of stuff on it. Like it would be like, you know, call number or something. So I can actually test to see if I get a result back. That is one extremely simple but extremely awesome things pointers can do. Now other languages have, like C# has null for a return value. That works fine. And it's not really a pointer. It just sort of all rolls into one. And I think basically every other language in the world has it now too, but back in the day this was a fucking game changer, for at least when I was learning it. So that's one cool thing you can do. The second cool thing you can do is, and I've just like drawn a blank, is you can actually create dynamic arrays. Now, you know what arrays are. So what are dynamic arrays? As I type them in because I cannot remember the goddamn syntax. Whew. A dynamic array is an array that you don't have to set the size of at compile time. So when I did, what lesson was arrays? It was 2 ago, so 7. If I can click the right thing. So down here, when I created this two-dimensional array, I'm going to skip past that. When I created this one-dimensional array up here, I had to give it a number of things it can store, which is 10. The reason for that is this memory that you allocate is allocated at compile time, basically. All of it's ready to go at compile time. So when you run the program, it's there. The issue with that is if I want to go, hey, how many numbers do you want me to store to the user? And they give me 12. I might have to put in some kind of failsafe where it's, oh, I better store 100. But if they only want 12, they only want 5, I'm wasting all this memory, and it's ridiculous. It's not great. So let me just comment all this shit out. If you want to know what the shortcut for that is, it's Control-KC to comment and Control-KU to uncomment. What we can do is we can create a pointer to ints called, you know, my numbers, my array, or whatever. Now, this pointer will still be a pointer to a memory address. But if you remember back to the array things, arrays, the actual like variable stores the first memory address. And then you use the square brackets to go that many memory addresses over. So this is basically the same thing as creating an integer array. It's literally the same thing. And we just go, my numbers is equal to, or actually, let's do it in the way I actually said. Let's go int numbers equal to 0. We go standard cn numbers, and we can go my numbers is equal to, that's the wrong way, is equal to int numbers. Pretty sure that's the syntax. Nope. That's right. New int numbers. I should know that. So now we actually have dynamic memory allocation. So let's have a look at how that actually works and why it's so good. So how many numbers do I want? You can have a look now. My memory is sitting at 1008 kilobytes. I'm going to say I want, say 100 numbers. Did it work? I don't know if it worked. Let's do a slightly bigger number. Let's do 10,000, whatever that is. And look at that. The memory has jumped up to 5 meg. That is an insanely large jump. Because that is, yeah, that is 1 million ints, which is 4 million bytes, which is 4 megabytes. So it's jumped up by 4 meg. Fantastic. I can now store 1 million ints. So that's what the whole point of this is. Let's say that, you know, for ints, 4 meg of memory, you have 16 gig in your computer, just say, or what's the point of me optimizing for this? Well, ints are an insanely simple example. Let's create something fun. Let's create a struct, and let's have, whoops, you know, a bunch of strings in it. Let's have a bunch of numbers in it. Let's have a bunch of floats in it, apparently. FL Whoops. I do that so much at work too. I go down to the wrong line. And just to really send it home, let's then create a character array. No, it's the wrong way around, isn't it? I always forget that, of chars, which is that big. This is an extremely large object. Let's just create one, okay? Let's comment. Yeah, let's comment all this out for now. And let's just create one single PBE. And make sure we set something FL to 3.1. All right. What is our RAM usage sitting at? Oh, what have I done? I've broken something. I think I've actually run out of memory. Yes, I've made it too big. You can do that. You have a certain amount of memory you can use, and we'll talk about that. So it's 2 megabytes. This one object is 2 megabytes. Now let's just say this was actually a phone book entry. If you're having to store 1 million of these things, or potentially more, I mean, there's 25 million people in Australia. Obviously not everyone's going to have a phone book entry, but if you have to store now 25 million, you're going to go, well, my software is going to be obsolete in a year if I don't store 28 million or I don't store 30 million. So I'm just going to go up and say, fuck it, I want my software to be good for years and years and years. I'll store 50 million. All right, cool. Let's make this 50 million. And set the first one to... Oh, don't be a jerk. Array is too large. 5 million? Too large. Too large? Too large. Are you fucking serious? How about 50? All right, 50. Yeah, and I've already run out of memory. So you can see the problem here. We're actually running out of memory to create these objects because we're trying to create what's called the stack. Now, the stack contains the most important thing, which is your function pointer, which is, it tells you whereabouts in the program you actually are, as well as where you've come from. And it's called the call stack. And those things are extremely important, but they're very limited in memory. Everything you create that isn't a pointer is created on the stack. And that becomes very important. We have 16 gig of RAM, but we're creating a, how big was this object? Like 4 meg? A 4 meg object 50 times. So that's 200 meg, and we're running out of RAM. That is ridiculous. Let's change this around a little bit. Let's change this to an array of pointers. So we're creating 50 pointers to the objects, as well as the 50 objects themselves. Are we creating 50 objects themselves? I'm doubting myself because I haven't done this in so long. By the way, we actually aren't actually using the RAM. I'm going to say we're not. So let's go for int I equals 0, I less than 50, plus plus I. Let's go I is equal to new PBE. Yeah, that's right. Yeah, that's right. And you'll see now we're using up 54 meg of RAM. And it's fine. It didn't crash. We can now increase this to 500. It takes a while, but there we are. We're using half a gig of RAM, and that works. Whereas if we were to take that out and comment this, it's just going to crash. Stack Overflow. That's the name of the website, Stack Overflow, where everyone just copies and pastes code from. A Stack Overflow is you've actually run out of RAM in your stack and it's just gone off everywhere. It's much like filling up a cup a bit too much. So that's one reason why pointers are very great. Now, in languages like C#, you just have one heap of memory. And when you create pointers, you're creating data it's called on the heap. It's like a heap of clothes, it just goes everywhere. Whereas a stack is RAM that you specifically own. So let's undo that and go back to this. So we've created 500 of these, but you saw we had to sort of change this. What we can do is we can actually just go int number of PBEs. Inc instead of cin, number of PBEs, and then do this. Alright, as I said, it has been a little while since I've done this kind of stuff, and I forget very rapidly how to use arrays and then pointers of arrays and arrays of pointers and all that kind of stuff. But when you do this, it actually creates it just much like a normal array would. It creates all the objects underneath. But the issue is that, once again, we're not creating pointers, we're creating an array. So we're creating a dynamic array. So we can go, we want 1,000 objects, and you'll see it goes and it's created a gig of RAM fairly rapidly, which is good. We can tell the thing exactly how many we want. We can have a descriptor of our phone book that says there's 1,000 entries, and we can do that. And we add one, we can change it to 1,001. A little bit inefficient, but we can do that. So this is great, but we're still now having the issue where we have PBEs instead of pointers to PBEs. We can't pass these things around. So what we can do is we can create an array of pointers. Much like this is creating a dynamic array using a pointer, we want pointers to pointers. So the way we do that is just double star and a star there. And then this here should now work. Yep, cool. So if we get to this point, we're just going to stop. And we're going to say we want 1,000 of these things. And that RAM usage, it has not jumped yet, because all we've done is create the array of pointers, but they're all pointing to nothing. And this O by CD, 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 that is the debug version of null. It's something you haven't initialized yet. And this first number here, 00144FE8, that's actually where the array of pointers starts. So now if we go through, we can go and we can actually see the RAM start to climb. So after 7 meg, still 7 meg, come on, update, whatever. Get to the end, and all of a sudden we're at a gig. There's that nice ramp up there. So we can do this, and actually we could create something where we do create 1,000 objects, and they're ready to go, or at least the pointers are ready to go, and then when we actually need them, we can create those objects. So we can do something like, if we have, I don't remember if you guys remember initializers or constructors from the last lesson. We talked about constructors. If we had this constructor up here for PBEs, so I go PBE string A, whatever, and name is equal to A. Instead of going and creating is that legal? Yes, I guess the other thing about structs is they're not explicit constructors if you set one. But anyway, this is great if we just want empty objects. But if we do want to actually initialize the data as we go, we can create this empty array. It doesn't bother creating the objects for us, and then we can go, you know, this will be data from file or something, some entry from a database, some entry from a file, something that the user has given us. And then we're not having to double handle those entries. We don't have to create the object, set everything out, set everything to nothing, and then go and assign the data. You do it all in one fell swoop, and it's actually a lot faster because you're not double handling stuff. This all does seem a little bit confusing, I know, probably due to the fact that I'm really bad at explaining them, but it's extremely important to just understand the base concepts, and more than that, just understanding what the star means. The star is a star. It is fantastic. And you can do all kinds of funky stuff with it. Specifically passing values. Oh, well, let me just explain that in a second. But like passing things to another function like this, we can actually give it the actual value to work on. So you don't have to do a copy. You can do direct editing and stuff. The other thing you can do with this kind of stuff is send constant references, constant pointers, so like this, const, much like the normal thing is, this means that this function cannot edit. So you see it must be a modifiable value, but we've sent in a constant. So you can do that if you want to send in a reference to the object or a pointer to the object, but you don't want them to be able to edit it, just read it. You can send in a constant pointer. That still works, and they can be created on the fly as well. So let's talk about why, or the terminology behind these things when you are doing different things with them. So let's talk about this function. So right now, well, let's go the old way first. Funct int a. This might throw up an error because it's ambiguous, but it doesn't matter. So right here, the difference between this here is known as pass by value. We are passing in a value, a concrete value. When we pass in this guy here, which I've commented out, we're actually going to pass in the number 5. Not a memory address, but the actual number 5. That's all they know about it. They know the value. That's why it's called pass by value. This here, in case you didn't guess, is called pass by pointer. I think that's what they call it, because there's 3 of them. It's pass by pointer, pass by... Oh, see, I second guess myself, and I can't remember what they're called. I'm fairly sure, yeah, it's pass by pointer. It's like the most simple stuff, and I forget it. It's known as passing by pointer, because we're actually passing across the pointer to something. And there is a third one, which we're going to go through just quickly. It's called pass by reference. So that's int at a. The at signifies a reference, and it works much the same way as the pointer one will. Now, the only difference here is this must be, or the main difference is this must have a value. You can't have a reference to nothing. It has to be an obvious. So I call this funct. What's its reference? Funct pointer and funct value. And we just go a equals 50, a equals 50, a equals 50. And we comment out this and just go int a, b, c is equal to 1. That's setting them all to 1. A bit of shorthand. So that funct v a, funct pointer b. Now this should, no, it's not going to magically do it. Oh yeah, sorry. So the confusing thing about this is, and I'll explain it as we go, is C. So generally speaking, it will that's one way of doing it, I guess. Generally speaking, it will actually convert a reference for you. It'll know how to do that. But a pointer you have to be more explicit about. And this at symbol will go, get the memory address of this. It basically is creating a pointer on the fly. And that's how you go up and down the pointer stacks. So then let's go standard cout, A, B, C. Let's see what happens. It doesn't work. Really? I thought, maybe I'm thinking of a different language. So 1, 1, 50. Well, what have we here? We have passed a pointer, a reference to a pointer, but it's actually created a copy. So that's bad. That's bad. So let's actually do it properly. So int star b is equal to new int 1, and then int at c is equal to 1. Must be an L value. Okay. Does that work? Oops. Once again, I don't use references very often. Int 1. That one? Why don't I remember how to do this? A. That's right. So a reference is like a hard pointer to something else. And if I'm correct, because goddamn if I fuck this up so badly, I don't remember half this stuff. Just some absolute travesty of code, because I forgot to do an and. No, I forgot to do a asterisk. Man, I'm so confused with pointers. Even now, after 15 years, I don't know how to use pointers properly. Probably why I didn't get that one job. And look, I have done it wrong because I'm so bad at my job. What do I do? What have I done? Needs to be like that is equal to 50. That one is equal to 50. Most of my life when I do C++, I spent trying to figure out if I have to use the at or this asterisk. All right, now they're all 50. That's what I wanted to see. So what's happened? What has happened is, so this first one, if I was to do this, and if I can remember how to code, man, I know like the whole point of this for myself to sort of do it in such an unedited way is to show all my flaws, because like I'm actually a pretty good software engineer. I know, big head and all that. But you just forget things that you don't do very often. I have not used C++ in about 6-7 months since I left my last job. And the knowledge of this stuff, while still I have a basic knowledge of it, I just forget the syntax so often. So we run it through funct v, which is passed by value, and it comes back as 1. That's what we expect. It makes a copy and it does a thing. Now, we pass the pointer through, then we have the exact value, which we then go and say, get the actual value of 50 of A, which is the pointer, and set it to 50. So we've gone through the chain and set that value. Then we have pass by reference here, and we are passing a reference to A. So we have basically passed that handle A through via this C thing. And as a result, it's then edited this A up here to 50. So what the pass by value could not do, it's done it there. Now the advantage of something like this is that you cannot directly delete a reference, but you can't have an empty reference. You always must have something. If you want to have something uninitialized, like our PBEs, you can't have that. And as a result, I don't really see references used all that often. It can be handy. I haven't found many ways to actually use references in my coding. But once again, that is completely up to how you use it. For the most part, pointers are going to be your friend. So let's talk about, I guess I've already given you the real world example with the search function. That is an extremely real world example. Pretty much every search function I've ever seen anybody write is this. It'd be like for int I equals 0, I less than size of array, plus I, and then if objects I is equal to name, or dot name is equal to name, then return objects I. And it'll keep looping through this loop until it finds that. And if it doesn't find it, it'll just return nothing, which is what you'd expect, a normal find to do. You're going to go, hey, go to the fridge, can you get me a Coke? It's like, oh, I got no Coke, I'm going to bring you back nothing. Is Pepsi okay? So that's the kind of thing you use it for. But more importantly, it could be something like, the user input is this, but it's translated into nothing, or I guess really searching. Or you can say, hey, I've actually got nothing to give you to work on. Can you just do something separate? I can't actually think of anything to do. Oh yeah, so it's uninitialized. You haven't actually told me to create this thing yet. You can do funky stuff with that, which I will talk about. I don't think in these sets of lessons, because they're pretty, advanced things, but there are these things called design patterns that you can use, and they heavily use pointers and nulls and stuff like that. I can't really think of much else to talk about with pointers. This is a lot shorter than I thought it would be, which is interesting. I really hope I've done it justice, because it is a difficult topic. But the basic gist of it is new and delete are your two new functions. Pointers are just, they're me pointing for you to go somewhere else. It's an address to some other piece of data. And the importance of that is it stops it from having to copy an entire thing. Like I said with that PBE example here. If I was to pass in, if I wanted to send over an entire array of PBEs, I'd have to copy them all. That's like 2 gig of RAM. That's ridiculous. But if I send a pointer to the array, that's 8K. It's 8 bytes, sorry. That's like magnitudes smaller, and it'll be much easier for you to work on. It must be easier for me to send to you and all that kind of fun stuff. Go away. Stupid flies. It's back. So I haven't showed you many like real world examples for this. I haven't shown you the most important thing. Holy shit. No, I haven't. Oh man. Okay. Sorry. So, pointers have a little bit of something different. So let's just get rid of this for a second so it's a bit easier to create. So let's get rid of all this. Okay, let's get rid of that as well. Up here with that. So let's create a new PBE pointer. PBE pointer my thing equal to new PBE. Now, if you remember a little bit in the last episode with this pointers, we used the little arrow. So let's talk about that. The arrow is actually saying you've got a pointer, but you want to access something inside the class that is contained inside the pointer. It is a shortcut of doing, what is it? It will be star my thing, like that. Dot that is equal to 1.0f. That there, which is we're grabbing the object stored in the pointer and we're going inside of it and going to FL. You can shortcut that to just be my thing FL is equal to 1.0f. This is a lot neater, and it's got the little point thing going for it, which I quite like. But that's what that is there, because you will see this everywhere. You will see the arrow everywhere. All it is saying is, instead of like doing PBE my other thing, and then my other thing dot FL is equal to 3.0f, instead of doing this, because we've got an object, and here we have a pointer to an object, that's how we get inside of an object that is being pointed to rather than getting inside of an object. That is a very key difference. And generally speaking, when you're talking about pointers, they're usually used for custom data classes. They're not really much used for integers and chars and all the basic types because they are so small. And the overhead of creating a pointer, like a pointer is 8 bytes, and an int is 8 bytes. So then you have to create 16 bytes of data for an 8-byte thing. It doesn't really make much sense. A char especially, a char could be 1 byte if it's like a short char or a short, and you're going to create an 8-byte pointer for it. That's ridiculous. Why would you do that? So it doesn't. So you don't use it for that. You don't use it in things like loops. You don't go int star I equals new int 0 and then dereference it. That's a pain in the ass. But you use it for classes because then you have this handy arrow majiggy, which gives you access to the thing. Then it's the same thing with functions. Void my func. My lovely lady funcs. You just do my thing, my func. Oops. And it's the same thing. It's just a different way to access a piece of data inside of a pointer rather than not inside of a pointer. And when we go into, the next lesson is going to be more class stuff. And when we go into it, I think pointers and classes, you can see them smashed together. and why pointers are somewhat necessary, but also you're probably thinking, why do we actually need them as well? And I mean, that's why for the most part, like new languages sort of got rid of them, and they do all the management underneath. But when you're doing memory management, you don't have the overhead of someone else looking for your garbage. You know where your garbage is. And that's what it's actually called. It's called garbage collecting, when something automatically does it. And the main advantage is that you can then manage your own memory, and you don't have to worry about some overhead for someone else managing your memory, because you know where your rubbish is. You just go to the bin and toss it out. But if I call someone else, I have to look through my entire house for all my bins, and that takes more time. So that's why doing it manually can be good. When you're looking for the most raw power, you obviously want to be doing it yourself, but it's also extremely dangerous, because if you forget to do this, and this function, I mean, this is the main function, so once it goes out of scope, the program just closes, so it's not really a big deal. But if I go up to here and go, in star, or say PBE star, new PBE, once this falls out of scope, I'll never ever be able to delete this, and that's a pain in the ass. It'll be an even more pain in the ass to find. So be very careful. Make sure that where necessary, in stuff like this, you always match up your new with the delete. If we're returning a pointer like this, we should be explicitly saying memory management done, owned by you, the user. Because generally when you return a pointer, you don't want to be deleting it, generally speaking. I can't really think of a reason why you would. And stuff like that. You got to be very, very careful about how you actually use pointers. You have to make sure that check and balance is in, where if there's a new, there's a delete somewhere. Otherwise, you get that thing where we saw before, where the RAM jumps up and it crashes, and that's terrible. I feel like I'm rambling a little bit, so I'm going to leave it there. And in the next lesson, we're either going to be talking about inheritance or operators, and those will be the last two actual lessons, and it'll be like a tidy up lesson, like all the stuff that didn't fit that is important but not as important to get its own lesson. And then we're actually going to put it all together, and we're going to make Battleship. So that's going to be fun. I hope you've enjoyed this. I hope I didn't ramble too much. I hope you've actually learnt something. If you have or you haven't, please let me know. I might have to do a follow-up for this one, but we'll see. And I'll catch you next time.